And today's webinar is called Accelerating JSON Queries with Multi-Value Hash Indexes. As for my introduction, I'm Yukti, and I'll be your host for today's webinar. And one of my main jobs here at SingleStore is to, run these webinars and produce them end to end and bring them to you. And we have amazing speakers with us on the panel today that are experts on the topic, and they'll be answering all your questions live. So feel free to use the Q&A button, which is present at the bottom of your console. And yeah, like you're currently in a listen only mode, and we will be addressing all the questions towards the end of the session. uh, and we'll have around 10 minutes, and you can ask any question that you might have, even if it's really small. We'll be happy to answer it. And we generally have a in company policy to address all the questions that we get live. So yeah, feel free to ask away, and we'll make sure to answer all your questions live. So yeah, these are certain housekeeping rules that we have made, and feel free to go through them. And yeah Spanna, you can maybe skip the slide. And yeah, if you want to know more about us, I'll be pasting links to everything in the chat. We have a very active online presence, and you can follow our socials. You can check out our documentation and blogs for the latest news regarding the company, and latest product releases. And yeah, if there's anything else, our DMs are always open. We all are very active on LinkedIn, and feel free to shoot us an email or a message anytime on LinkedIn. Yeah, we are very happy to be in touch. So for today's webinar, we have Spandana and Vyashaliv, who, sorry if I didn't pronounce the name correctly. So uh, Vaishslav. Okay.
You can call
Can
me
you pronounce?
Slava.
You can call
Yeah.
Slava. Yes.
Oh yeah, I'm so sorry. Oh my God.
Yeah, no
So
worries, no worries.
yeah, so we have amazing speakers with us today that are experts on the topic. And if there's any questions, send it to them directly, and they'll be more than happy to answer your questions live. And yeah, Spandana, please take it away. And thank you so much for your time and agreeing to do this webinar with us.
Yeah. Hey everyone. So yeah, even my name is a tongue twister. So yeah, everybody's names are until you know them. Yeah. So I'm Spanna working on as a product manager on different areas of our single store database offerings like ingestion as a capability and also the semi-structured JSON functionalities as well as the Mongo API compatibility. And we have Slava, who is a senior engineer who has actually worked on bringing a lot of features to life on the database. So today's agenda, yeah, definitely is going to be a little bit of introduction on single store for those of you who are hearing about single store for the first time, what it is about, and quickly we'll move on to the topic of the day about JSON and semi-structured data and what are the uh, demanding use cases in the modern day applications for JSON that everybody's trying to solve, and what are the different challenges people face, and how is single store's JSON uniquely positioned to solve them. And we'll also look into how single store as a database can understand both SQL as well as Mongo API. And we'll further look into what are the indexing strategies that are possible on the JSON data to further improve the optimization, to add more optimization on your queries. And we'll end with a demo where you will see firsthand on what are the benefits of the multi-value index, which is the key index that we are going to discuss today. Yeah. And we leave the floor open for question answers at the end. So to say, what's single store? Tell it in brief words, it's the fastest data platform for apps and analytics at scale. So there are many features that are powering all these functionalities. So if you go in uh, further detail into all these key terminologies, when we talk about apps, so single store is a database that supports apps as the single source of truth. So single store is the database that can support the apps for the OLTP workloads. So it's the database that's built for apps. So it runs transactions and it is ACID compliant, and it operates on a huge concurrent scale of queries and at millisecond offers results at millisecond latencies, and all these at scales both in terms of the huge volume of data that you can store and as well as the queries that you can run. And along with it being a fully ACID compliant transactional database, SingleStore also powers the analytics. So this is the rare combination that uniquely positions SingleStore for modern day applications, because all these together at one place is definitely rare. Being able to support transactions, analytics, as well as the search and multi-modal workloads, both text search as well as powering the semantic search for the yeah Gen AI use cases for your LLMs and agents, and all this at the scale that modern applications demand. So, along with the uh, highly resilient and solid database, SingleStore also offers several developer-friendly features like integrated Python notebooks, where you can code in your language of preference, be it SQL or Python. And we also have the GPU compute hosted inside SingleStore, so that your data need not leave the database, go elsewhere for powering the high intensive machine learning and model training workloads. So we have GPU compute and the vector search, index to vector search capabilities, which everything you can do all in one single place. So, how is SingleStore able to power such a diverse variety of use cases? It's mainly due to the way it is built. So, so SingleStore supports high throughput ingestion from a wide variety of sources natively. So, you need not actually have extra setup and infrastructure for bringing data from different places like cloud storages or streaming systems like Kafka or other databases, be it MySQL or Postgres. So SingleStore offers native way to bring data at high speed in a highly resilient manner, available manner into the database. And as soon as the data comes into SingleStore, so yeah, these sources are just one style of bringing data. You can use your SQL statements like insert many, and load data as well to push data into SingleStore. And once the data lands into SingleStore, we have this memory layer where the ingestion is quite fast because it's in memory, and it can support high concurrent inserts and updates in parallel without blocking your other workloads. So after the data lands into memory, so there is a periodic job that pushes it into the persistent disk where the data is available, all the hot data that you generally use for your read queries or any of your analytical or transactional workloads. So all the hot data is available immediately on the disk, so to power low latency reads. And at the end, you see the third layer, which is the unlimited storage, where you can store literally unlimited volume of your cold data, which doesn't really have any limit. So this is supported by object storage. So together it is called universal storage, the three-tier architecture that is able to support the high throughput queries, as well as the way the data is stored the in memory. It's stored in the row oriented structure, whereas in the disk it is disk and the unlimited storage, cloud storage part. So it is stored in the columnar format, which actually gives you huge performance gains when you are running analytical or OLAP queries on huge volumes of data. So this is how the storage is. And coming to this picture, it is about once your query lands into the database from your users or your application. So uh, the the compute engines in the single store database, they automatically forward it in a distributed manner to the natively sharded leaves that we call them. So all the queries are executed in a highly distributed manner, which is quite efficient and is able to return the results in millisecond time. Yeah, so to sum it up, it's SingleStore supports streaming ingestion with and powers all the different types of workloads with this unique three-tier architecture. And the uh, the way that the compute architecture is designed, it's with a shared nothing architecture where your all the different nodes of your distributed engine can work in parallel to serve queries within milliseconds to your users and give that interactive query speed and responsive applications. So now coming to JSON. So JSON is a data type in SingleStore. It's a so it is a type just like how you use general scalar types like string, int. You can actually create a table with a column called JSON. So why is JSON so important? uh, because it is growing in popularity. It's already has grown into popularity, and it is powering a lot of diverse use cases across different verticals, be it IoT, streaming, event streaming, logging, take e-commerce data, the way that yeah, the product information, the orders, everything is getting operated in the apps in a yeah, JSON format, and the same format is kind of transmitted to the database and is getting stored there. And the other advantage of JSON is it's both understandable by both the machine as well as human readable. So that way, it is becoming quite interoperable across many industries, and it's quite flexible. There's not really any rigid schema for it. And so, why is JSON loved by developers? So, if we look into the strict relational database paradigm on the left hand side, so if a developer wants to start building any app, the first step once the app layer is done is to think about how to store the data in the database. And in a strictly relational SQL world, one has to start with the schema and model the relationships, entities, and come up with uh, the actual entity model, entity diagrams, etc. And this itself adds a lot of rigidity. And in the beginning phases of your app development, as the product is continuously evolving, as the app is evolving according to customer needs, there would be a lot of times where you want to make some changes to the schema, and that requires yeah, its own process of doing the schema migrations, requiring some precursor before you can actually change data in your app. So yeah, all this adds certain overhead in the application development. Though the format is pretty efficient, it supports huge complex queries with joins and offers a powerful query language. So these are the limitations when we really have to do it in a model it in a columnar format. Then we have another world called NoSQL or document databases where developer need not really worry about designing the schema. You can directly bring the object of your app, the data object, and put it in the database in the exact same format. And if you really want to extend that object by adding a new column or a new field, you can do that without worrying about what to do with the previous objects that are already there, because the document or JSON or NoSQL is really flexible. So this way the developers get the flexibility that they need, and being ability to add fields or remove fields without worrying about breaking the database constructs. But the challenge with the NoSQL databases like MongoDB is, so the data is stored in a document format. So the entire JSON gets stored at a single place. And that way, when you really you can consider it like a row oriented format where all the fields of the JSON sit in a same place. And when you really need analytics on, let's say, millions of rows or the JSON documents, yeah, the database really has to read the entire JSON, even though if you're doing a query on just one or two fields inside the JSON. So yeah, that the NoSQL databases have this bottleneck when you really need to have analytics. And that's where single store offers the best of both worlds. So single store is able to offer the flexibility that was missing in pure relational paradigm by offering the JSON column, wherein you need not split your data into ints, strings, and floats. Directly get the data into the database in the single column. And by offering the flexibility, it also overcomes the limitations of the NoSQL database, wherein it auto columnarizes the JSON. So this way, it gets the power, the analytical power of column-oriented databases. So each field in the JSON gets its own column, and user need not do any extra steps here. It's natively handled, and uh, all the columns in the JSON get their own subcolumns, and it is stored in a columnar format. And as yeah, it's widely known, columnar databases are great at the analytical queries. So to give a simple example, let's take this uh, particular JSON document, which just has holds city and the trip fare details. And this is the sample table that I created that can actually store this JSON into SingleStore. So as you have seen, I didn't really create a complex schema and didn't specify that city is a field, trip is a field, and inside that there is a nested fare. So you just need to create a JSON column, and you can directly insert this entire JSON document into this single row. And I'm trying to do a simple query here where I'm uh, finding out the average of the trip fare grouped by the city. So uh, if let's say here the example is just showing two documents, but if it's an actual live app like an Uber, there are millions and millions of cities and trips that are taken continuously. And even if you consider one day of data, that would be huge. And if you have to compute the average by bringing out all the columns in the JSON, it would be pretty heavy. So the example I showed here is pretty simplistic, but the JSON columns tend to be pretty complex with thousands of fields. Whereas the query what that you're doing is just about finding out the average fare. So what the columnar format offers an advantage is you can directly read the data of the fare or the price, and not ignore the rest of the data. You can leave it and without bringing it out into the memory. So this way, the IO required for your query is minimized, and the resource utilization is pretty low, and the query returns results pretty fast, and your users can actually see the query results in an interactive time and not show that continuous loading button. Yeah, so this is how internally the JSON is stored. Let's say if as JSON doesn't really enforce any schema, one of your row can be this, and the second row can have a new field added to it. And single store is smart enough to understand, infer the schema from all the rows that are present inside the column, and auto infer the sub columns so that it can store the data in a columnar format. So from this, it auto inferred that this is the structure. Like there are columns A, B, C, and C has a nested column D and E. And this data gets stored in its own columns. So it's like single store is designing that normalized schema for you. So you need not specifically mention to store A as a column, B as a column. Internally, it gets stored in the auto columnarized or sub columns. So the data is automatically shredded when you insert the data into the JSON column. And along with JSON, we have another optimized storage style of JSON called BSON, which is the binary encoded version of JSON, which is the format that's used by MongoDB. And as this is binary encoded, it has even performance advantages for certain type of queries. And with the BSON data type, SingleStore is able to serve all the MongoDB API requirements as well. So once you have the data in SingleStore, you can use both the SQL language and even the Mongo language. So if you are a Mongo API fan or you're a Mongo developer, you can run queries on the JSON data using the Mongo language that you already know. And as SingleStore supports BSON, there would be 100% data integrity and there wouldn't be any precision loss when converting from the Mongo's BSON to SingleStore. Along with the the optimized storage format for the we also have a lot of wide variety of built-ins, functional built-ins that help you run queries, uh, run pretty complex queries without you writing SQL queries by hand. Let's say JSON ag is about finding the aggregation of the items, and then array push, you can modify and massage your arrays on the JSON. Yeah, so extract. So all these are possible even by writing the queries by hand, like I have shown in the example. But all these built-ins, native built-ins, make the a developer time, reduce the developer time, and make developers really productive. Yeah, so the JSON with its unique storage format is already quite optimized, and most of the queries run pretty fast without any manual tuning or yeah, indexing strategies. But for certain highly selective queries where you want to focus on certain rows that match criteria, we have indexing available on the JSON column so that you would be able to create indexes on the fields that you're interested in for your queries. And the first style of indexing is the general column index that is possible on the scalar columns or the normal columns. So you would be able to promote a field into a column and create a normal hash index on top of it. And along with that, we also newly introduced in the recent 9.0 release for SingleStore some powerful indexing strategy called multi-value index. So the one of the a limitation or drawback with the persisted uh, column index is so the JSON data it's pretty flexible. So if you follow the path of the JSON, the path can lead to a single field, or the endpoint of the path can be a whole object itself, or it can be an array that store many values. So the the columnar hash index on the persisted data doesn't really support arrays because each array has in itself a lot of elements to be indexed. So that's the advantage that you get on multi-value index. So for the multi-value index, even though the JSON path you are interested in has an array, now all the elements in the array get indexed, and you would be able to do uh, quite efficient searching and finding on array elements level as well. And we also have full text index, which is powered by Lucene. So you would be able to do all the match queries using tokenizers and different language, yeah, lexicographic tokenizers you can build on it, and do fuzzy search, do key value mapping, and also use different powerful expressions that Java Lucene offers. So we'll look more in detail on the multi-value index, on how you can create it and what are the use cases that it powers. So Slava will be taking it over. Yeah,
Yeah, thank you, Spandana. Do you mind to continue presenting?
sure.
Awesome. Uh, yep. So yeah, we're introducing the new type of index called multi-value hash index. As you may see on the right side on the slide, we have an example of the JSON object. So it can be the output of your API or other systems. And here's the example about the reviews for the books. And imagine that you wanted uh, to perform fast lookups to know all the books that have rating of 5 or all the reviews of some particular person. And this new type of index allows you doing that. So in order to do that, we are using our powerful built-in function called JSON match any. So basically it returns a boolean based on the specific key passed to your object and by the predicate. Predicate can be the any type of Boolean expression. It can be equality operator. It can be in list. It can be even more advanced expressions. And in this example, for example, if you take a look at the reviews, and we would like to select all data that have the rating of 3 or 4, for instance. You might take a look that we have the reviewer Eve with rating 4 and reviewer Bob with rating 3 as well. So in order to do that, we need to call JSON match any function, and we need to provide the path to it. So it's basically we use column, key reviews, and sub key of rating. And the expression will be we have the placeholder called match param JSON. Basically, it dynamically replaces with the JSON that we are currently traversing. So in case of reviews and rating, it will be just the integer 3, 4, 5 in this example. And we are evaluating this placeholder value over our target. So in this case, it's 3 or 4. And we may depending on the input, we may return or not the exact values. So another example is reviewer name. So we are looking for all the reviews made by Eve. So you may take a look on the below example. So it's the same, but we changed the key path to it. So from reviews rating to reviews reviewer, and the match param. Sorry, Spana, can you go back to slides, please? Yeah, thanks. Yeah, and matching JSON equals to the string if. And on the right side, we also have the example of performing similar operations, but over our SingleStore Kai queries. So there it's much iconic and smaller. Yeah, next slide, please. Yeah, so under the hood, basically we are using our already existed column store secondary hash index. So in order to explain how it worked under the hood, I use the same example, but I highlighted the values of reviewer. So imagine we would like to index our reviewer name. So we would like to perform fast lookups based on the reviewer name and get all the related corresponding row IDs immediately. So in order to do that, we need to provide the key path to the index that we were looking for. So for our case, it can be reviews and sub-key reviewer. So how it works under the hood. We are looking at all values under this particular key path. In our case, it's only 4 strings: Alice, Eve, twice, and Bob. Per each string, we are calculating hash function. So basically, it takes the string as input and it returns integer as output, because operating over integers is faster, and it's a way to, and it's smaller for storage purposes. And basically, per each hash value, we also add in the list of corresponding table row IDs. So for the Alice, we see that we have the only occurrences for the first ID object of the JSON. For the Eve, it occurred twice, for the first one and the second one. And for the Bob, it occurred only for the third JSON object. So once we build that index, if we want to perform matching, we need to how it works. So basically, you're providing the Boolean expression using our already mentioned JSON match any function. You're providing the predicate. In our case, that JSON string should be equal to the if, and we will perform the hash function over if string, and it will give us corresponding table row IDs, which for our case is the first and second one objects. And so this case will give us the exact corresponding row IDs, and we simply materialize the rows under that particular row IDs. Next slide, please. Yeah, so the syntax for it, so you may either create the syntax immediately when you're creating the table, or if you already have the table with the data, you can simply alter it, adding your index. So the syntax for it is called multi-value index, where you, in brackets, you're specifying the JSON or BSON columns that you would like to be indexed. And then you have index options. Index options is also a JSON object, which tells the indexer how to index or tokenize the data. So it has exactly two arguments: tokenizer. For now, it's only match any corresponding to the JSON match any function. And the path, it can be the empty array, meaning that we would like to index the top level JSON array, or it can be passed to some sub values or sub documents. So the example below is that we would like to access addresses and then the city. And the index is quite smart to understand if it's the object, then we would access sub-object of that. But if we have an array of objects, we also would access all elements of that array. Next slide, please. Yeah, it was we were inspired when developing that by famous open source Postgres GIN index, known as generalized inverted index. So you may find the similar things, and it allows either migration from the Postgres to SingleStore. It currently works on both JSON and BSON data types. And we index only specific key paths. So if you would like to perform fast lookups based on two keys, like you would like to fast lookup at the same time for the reviewer name and for the rating, you would need to create two separate indexes. Next slide, please. Yep, and in order to understand that your index was actually invoked or applied, you can use explain command by adding the explain word before your select query. And if you would see near the column store filter that you have the phrase multi-value hash index, it means that our hash index was involved, and it gives you the fast lookup for your predicate. Yeah, that's all from me. Thanks.
Yeah, so we'll quickly look into a demo on how multi-value index makes a difference in the query latency for huge volumes of data for the highly selective queries. So this is my SingleStore portal. The cloud portal. Once you log into singlestore.com and create your account, you get 600 free credits that you can use to create a sample workspace and directly get to running your queries. So for this, I already have created a database called multi-value here and preloaded certain tables. So just to show how the tables are, so this particular data is from the TPCH. Uh, we have two tables called orders and product IDs as part of TPCH. And this is a transformed version where the orders as well as the product IDs that belong to an order are kind of joined into a single table in the denormalized fashion. That's generally pretty common in the NoSQL document databases. So here you can see that the order ID when it was created and all the products that are part of this particular order. And what I'm generally interested in here is I have a particular product ID in mind, and I want to really see in how many orders was it part of, which product ID is pretty popular, which product is actually selling quite fast. And those kind of queries are yeah, if you have certain product that you really want to understand the analytics, sales analytics on top of it, you would want to search for the orders where there is a particular product in its cart or in the order list. So in this case, I have picked an product ID of 20765, and let me uh, yeah, run this query to find out all the orders where that contain this particular product ID. And this is the syntax where you have the table and you are giving the path. So in this case, this array is directly on the top level. So I'm directly giving the column name here. Let's say if this array is deeply nested inside, you can specify the path to that key. So in this case, it's on the top level. So I just directly give the product ID's column name, and I'm matching for this particular number. Uh, and yeah, let me quickly run it to show you how fast it is. And yeah, it runs in milliseconds. But now let me show you how many yeah, rows are there in it. It's almost 10 million rows, and it runs pretty fast. This is because I already created the multi-value index on top of the product IDs array. And I have taken the same table and created a copy and removed the index here. So this doesn't really have any index. And so this also has the same schema, just that it doesn't have the index. So you can even quickly check. So if I go here, orders table, this is the SQL schema for how the table is created. And you can see that the orders table has particular key created on the product IDs column, and the index options match any, and the path is top level. That's why it is empty. And the orders without index also has the same structure, but it doesn't have the multi-value index. Now let me run the same query on the other table, and yeah, it's going to give us some time. And I want to show just that this table also has the same count of rows. So without an index, what this query has to do is it would have to go through all the rows, go row by row, and go through each item in the array to see if this particular number is there, this particular product ID is there. So searches for that number in the row 1, row 2, row 3, and it goes till all the 10 million rows. And yeah, so yeah, it returned back in 30 seconds. So that is the advantage that you get by indexing the values that are of interest to you, so that as the values are already indexed, it can directly point and reach the rows immediately. Yeah, so you can quickly see that the huge magnitude of performance gains that you got where the query returns in milliseconds versus something which doesn't have an index. Yeah, so both the tables are having the same count. And to show you how to see whether the index is used or not, you can directly go through the query profile. You can find the query profile using the explain before the query, which shows you, yeah, that what are the steps the query has taken to execute. And it is using this filter. It's using the hash index for executing the column store filter. If I do the same, yeah, it'll take a while. I really wanted to show the another way of looking at the profile. We have something called visual profile, where it shows in a graphical representation whatever you saw in the textual format. Yeah, here as well you can see that, yeah, in the filter, the hash index is getting used. Let me go back to my editor. Yeah, I'll just leave it to run and we'll see if there are any further questions. Yeah, so yeah, as it's just an explain, it's not really running the query. So yeah, this one has the multi-value in it, and if the table doesn't really have any index, you would not be able to see that the filter is using any index, and that would take a lot of time. Yeah, so evaluate whether your workloads have certain JSON heavy queries, and the JSON is quite complex with nesting and arrays. So multi-value index is particularly something that can help uh, optimize your queries even further and give you millisecond response times, even on the most complex JSON objects that you may have. Yeah, all this with all the other capabilities of single store like fast joins and the unique column store execution, within which you will be able to run pretty complex queries at high concurrency with millisecond query latency. Yeah, thank you. That's all from our side today. So we'll wait for a couple of minutes if there are any questions, and Yukti can take over to talk about what's in store for, yeah, in the future webinars.
All right. Thank you so much, Spandana. It was so cool. And like, is there a link that we have to the demo? Like, if you have a GitHub repository?
Sure. We can definitely create one.
Yeah.
It's just that
Yeah.
the data set has to be loaded, but yeah, the queries are pretty simple.
Yeah, like it should, if like, like folks can like
Mm.
follow along. There's a lot of people like after the session, they join and like so basically some people are not able to join live. So like it's included in the follow-up email. So for everyone that has attended live or if you were not there in the beginning of the session, we will be sending a recording of the session along with all the resources. I saw that Slava has shared a link to a documentation that's relevant to the webinar. So that will also be included. And yeah, Spanda, if there's anything else that you would like to share, so like let me know. And to everyone that's attending, we are officially open for questions now. So if there's any questions that you would like the speakers to address, because they both are experts on the topic, please feel free to send them in. And if you're not, if there's no questions right now, but if you have something later, you can always reply to the follow-up email that you will get. It will directly come to me and I'll forward it to the speakers, or like we'll take care of that. So yeah, you can utilize the Q&A button which is present at the bottom of your console for any questions. So yeah, Spandana, like there was one question that that has been taken care of via text, but like do you want to take it up live? So do
Mhm.
you want to, can you read the question, or like do you want me to read the question?
Yeah, I'm not able to find it. Yeah, go
It's okay,
ahead.
I can read it. So,
Yeah.
there's a question from Cole. They say that is there a document or example of applying full text indexes to JSON columns?
Yeah, so we have a detailed documentation on how to use the full text index and do pretty complex queries on top of full text index. So we can share the documentation link. Can I do it on the chat?
Yeah, he's already done that. Like, I
Sure.
was thinking
Yeah.
to add something. So yeah, like then I think then we don't have any other questions. So yeah, then
I
I think
think
we
we
can.
have a raised hand in the
Oh,
participants.
yeah, so yeah, like for anyone that's attending live and maybe you guys joined late, so one of our housekeeping rules is that we don't take up any questions like by raising hand because everyone's in a listen only mode, so that's not possible. So if there's anything, you can utilize the Q&A button. It's like in the middle of the console, so you can utilize that. If I mean, and we can always take up questions via email as well. So yeah, I don't see any other questions coming in though. So yeah, Spanda, do you like would you be okay in
Yeah.
wrapping up?
Yeah. So we are well in time. So yeah.
Yeah. Okay. So, Slava, you have something else to share?
Nope.
Okay. So, yeah, thanks everyone for joining. We have amazing webinars that are going to be coming up in the future, and I'll make sure to include them in our email. So, if you like today's session, we will be more than happy to have you in other, in all our other webinars that are coming up in the future. So, yeah, there's a comment from William. Thank you for the informative webinar. Thanks so much for our speakers to, in actually putting this together. It takes a lot of time and energy. Of their busy schedules. So yeah, like we will be in front of you all with more informative free sessions. So yeah, stay tuned for my email and keep on checking our resources page. Okay, I don't have anything else, so I think we can conclude the webinar now. Okay,
Thank
thank you,
you.
everyone.